everyone. This is lesson 13.1 in Algebra 2, and today we are looking at some new trigonometric functions that you might not be as familiar with. These are the reciprocal trig functions. So you already know the main three trig functions, which are sine, cosine, and tangent. Today we're going to learn three more: the secant, the cosecant, and the cotangent. And these things are, just like the title says, the reciprocals of the trig functions that you already know. Now, I will tell you, I was not in charge of naming these because I would not have named them the way they are named. I look at secant and cosecant, and I think, oh, this goes with sine, and this goes with cosine, the way these things are named. And that's the exact opposite of what they actually are. The secant is the reciprocal of the cosine function. The cosecant is the reciprocal of the sine function. So that's sometimes a little bit hard to keep straight. I sometimes find myself even mixing that up a little bit. But so secant is the reciprocal of cosine. Cosecant is the reciprocal of sine. And just to remind you, reciprocal means you're taking a fraction and flipping it over. So remember, sine, cosine, tangent, all of those are ratios, meaning they can be written as fractions. And these are just those same fractions being written upside down. I guess we should throw in cotangent actually does correspond the way you would think it would. This is the reciprocal of the tangent function. Now, I'm going to throw something else in here. And I want to point out that I think your focus, and the reason I wrote this out in words, should be on the word reciprocal, because we all know how to take reciprocals. And if something is already a fraction, you just take that fraction and you flip it upside down. But if something is a whole number, like if I asked you for the reciprocal of 3, you take the reciprocal by saying, okay, it's 3 over 1, so I'm going to make it 1 over 3. So a lot of the times you'll see this written as 1 over the cosine. And this is written as 1 over the sine. And then, of course, 1 over the tangent. The reason I don't lead with that, the reason I don't start with writing them that way, is sometimes we lose sight of the fact that if it's already written as a fraction, and you're going to see that down here in these ones here, if it's already written as a fraction, you don't mess around with this 1. So, like, just as an example, and I don't know that you need to write this down, if I ask you for the reciprocal of 3, like I just said, you would tell me it's 1/3, because we can kind of pretend there's a 1 underneath this 3. But if I ask you for the reciprocal of 2/3, you wouldn't tell me it's 1 over 2/3. Okay, don't do that. That's wrong. All right, we don't like that. Instead, you would just flip the fraction over and make it 3 over 2. And as it turns out, that's exactly what this thing would be equal to, but it's just ugly to write a fraction inside a fraction. So if something is already a fraction, we don't mess around with the 1, okay? And you're going to see that kind of shown here in example 1. There's somewhere it's going to work like this, and there's somewhere it's going to work like this. And you just have to kind of know what it means to take a reciprocal. Okay, this is going to rely on you knowing your unit circle pretty well. And I'm just going to draw a quick sketch of one. I think I grabbed some paper here so that we can refer to it. And you'll get to see kind of my thought process for working my way around the circle as well. Okay, so the first question here is cosecant of 150. Well, remember, the cosecant really corresponds to the sine. All right, so before I can do the cosecant, what I really need to know is what is the sine of 150? Okay, that's the question that I'm asking myself. So I need to think about where 150 is on the circle. I know that's, so if this is 180 over here, 150 is going to be 30 degrees back from that. So that's the third dot down. This would be the 150. And I need the sine value, which is the y-coordinate. Okay, just to remind you, your coordinates are cosine, comma, sine. So I'm looking for the y-coordinate, which is the vertical value, right? The y-coordinate is always working up and down here. So what I really need to know is what's this length, okay? And anywhere on the circle, and we kind of talked about this when we filled in the circle initially, anytime you've got this triangle that's either at the first dot or the third dot, you've got kind of a short side and a long side, right? If I was going to fill this in, if I was going to make this a triangle, I've got a long side and a short side. And anytime you've got that long side, short side combo, the long side is square root of 3 over 2, and the short side is 1/2. And like I said, this is the one that I care about. And I also want to check to make sure it is positive because it's moving upward. So just to jot down my coordinate here, this, I know I labeled this square root of 3 over 2, but it's in a negative direction. So my x coordinate would be negative square root of 3 over 2. My y coordinate would be positive 1/2. And the y coordinate's what I really care about. So sine of 150, I can say, is positive 1/2. Okay. So now to do the cosecant, I am literally just taking the reciprocal of that value. So the cosecant of 150 would be 2 over 1, otherwise known as just 2. Okay, so all you're doing is finding the sine, cosine, or tangent on the unit circle and flipping it over. The one other step that I may add, and I think it happens in this next one, is we may have to do some rationalizing. Okay, and I'll show you that when we get there. But so secant of 315, secant goes along with the cosine. So what I really want is the cosine of 315. So on my circle, 315 degrees, remember all the way around is 360. So 315 is 45 degrees backwards from that. Okay, it's the middle dot in this fourth quadrant. Okay, those middle dots are always your isosceles triangles. So that's where this length and this length, if I drew this well, are exactly the same. Okay, and they're both square root of 2 over 2. Again, want to pay attention to my signs here, positive, negative. I'm looking for the cosine, which is the x value. So that would be this value right here, and that is in a positive direction. So I would say that my cosine of 315 is square root of 2 over 2. So now let's figure out what the secant would be. The secant is just that value flipped upside down. So secant of 315 degrees would be 2 over the square root of 2. Now the problem is I can't leave that like that. And I think we probably talked about this a little bit in the unit circle lesson, but I need to rationalize this. I can't leave a square root of 2 on the bottom of the fraction. So I'm going to multiply by square root of 2 over square root of 2, which is really just multiplying by 1. That's why I'm allowed to do it. That means that up on the top, I'll have 2 times the square root of 2. And on the bottom, square root of 2 times square root of 2, the square roots drop off of there, and I'm left with just a 2. And then this 2 and this 2 cancel, and my final answer would just be the square root of 2. Now, I know that seemed like a lot of steps, but you have to remember that this value is going to pop up a lot on the circle, right? There's going to be a lot of places where this is your value, or it could be negative. If it were negative, then this answer would just be negative, and that's okay. And every time you take a reciprocal, it's going to come out this exact same way. So after you do this a few times, you'll get to the point where as soon as you see this, you're like, oh, I know that that's just the square root of 2. Okay, so this is the rationalizing process, and you're going to want to know how to do that if you run into one that you don't remember, but it will start to come to you kind of quickly here. Okay. Cotangent of 9 pi over 4. So of course, the first thing we really need to think about is the tangent of 9 pi over 4. And that's going to depend on you being able to find 9 pi over 4 in the circle. So the pi over 4s, those are like your 45-degree angle. Those are your middle dots on the unit circle. And so I'm just going to fill in these other quadrants with my 3 dots here. Okay, so here's how I would find 9 pi over 4. I know that the pi over 4s are, like I said, the middle dots. So starting here, okay, 1 pi over 4 would take me to this middle dot. 2 pi, and I guess let's do this, and then you can be looking at the point of my pen here. So 1 pi over 4 takes me here, right? 2 pi over 4 takes me to like the 90-degree mark. 3 pi over 4 takes me to the middle. 4 pi over 4, which is the same as 1 pi, takes me to 180 degrees. Okay. 5 pi over 4 would be here. 6 pi over 4, which is the same as 3 pi over 2, takes me here. 7 pi over 4 goes to the middle here, and 8 pi over 4, which is the same as 2 pi, would take me to this, all the way around. And let me just jot that down for reference, that 8 pi over 4 is the same thing as 2 pi, and that's what we would normally call this point in radian land. Okay, so we're at 8 pi over 4, and then I'm going to turn one more to get to 9 pi over 4. So this middle dot here is the same thing as 9 pi over 4. As you get better and better at the circle, what I'm hoping you'll be able to do is kind of use this as a reference point. So you can say, well, I know 9 pi over 4 is bigger than 2 pi. So think about 2 pi in terms of pi over 4. All right, that'd be 8 pi over 4. And then think about how much further you'd have to go. But you can always count your way around the circle that way. Okay, so I just went 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and that takes me to 9 pi over 4. All right, now let's talk coordinates. I want the tangent. Now this would be another one where the two sides are exactly the same. It would be a square root of 2 over 2 and a square root of 2 over 2 for the sine and cosine. Remember, I want the tangent, which is the sine divided by the cosine. These ones I encourage you to just kind of memorize, but the tangent here would be 1. Okay, the tangent at pi over 4 is equal to 1. And so then the cotangent would be the reciprocal of 1. So I guess if I was being formal about that, it's really 1 over 1, which is just the same thing as 1. So the tangent and the cotangent are exactly the same at those points. Okay. All right, and last one, secant of negative pi over 2. Well, secant is associated with the cosine. So really I need to know the cosine of negative pi over 2. All right, so negative pi over 2 means I'm starting here and going backwards by a value of pi over 2, and pi over 2 is 90 degrees, so this would be negative pi over 2 right here. This point, if I'm thinking about my coordinate plane, has an x-coordinate of 0 and a y-coordinate of negative 1. And I wanted the cosine, which is 0. So cosine of negative pi over 2 is 0. So let's think about the secant. So the secant of negative pi over 2 is the reciprocal of 0. Now, I want you to think about this 0 as being 0 over anything. I mean, 0 over 1, 0 over 5, 0 over whatever. A 0 over anything is always just 0. So the reciprocal is going to be something over 0. It would be like 1 over 0. And that should be throwing up some red flags in your mind. We can't do this, right? We can't have a 0 on the bottom. So I would cross this off and I would say that this value is undefined. Okay, we're going to explore the undefined values a little bit more down here, but we have to think about that because these things are reciprocals, anywhere the cosine or the sine or the tangent is equal to 0, we're going to end up into some trouble here with these fractions, right? Because we can't have zeros on the bottoms of our fractions. So, like I said, we're going to talk about that a little more on the bottom. Okay, so this concept of the undefined values is going to be an important one in the next couple of weeks here. So we're going to write this down here, and it by far will not be the last time we talk about it. First of all, just plain old sine and cosine. So if I'm thinking about the circle, okay, and you may want to sketch the circle off to the side here. If I'm just thinking about plain old sine and cosine, those are the x and y values on the circle. And there's nowhere that I can't find a sine or cosine. I can always find an x coordinate. I can always find a y coordinate. So there are no undefined values for sine and cosine. These ones don't give us any trouble. Tangent. We've talked about tangent before, right? Having undefined values. That tangent on the unit circle is equal to sine over cosine. So anywhere the cosine is equal to 0, we're going to have undefined values. Let's just leave that there for just a second. Let's talk about these three real quick, and then I'm going to associate that back to the circle. So the cosecant is 1 over the cosine, we said. So just like the tangent, anytime the cosine is equal to 0, we're going to have undefined values. The secant, oh, I did that wrong. See, I told you I mixed these up. So sorry, guys. That's not 1 over the cosine. The cosecant goes with the sine, which is why I ordered it that way. So this is 1 over sine. So this is a problem when sine equals 0. The secant is 1 over cosine. So this one's a problem when cosine is equal to 0. Okay, sorry about that mix-up. Make sure you change it in your notes. Okay, if cotangent is the reciprocal of tangent, and tangent is sine over cosine, that means the cotangent is cosine over sine, meaning this one gives us problems when sine is equal to 0. So you will notice that these two are going to be undefined at the same time because they both have cosine on the bottom, and these two, are going to be undefined at the same time because they both have sine at the bottom. So now let's think about our circle. The zeros happen at the 4 corners, right? These are going to be the 4 places where we run into issues, okay? And at this coordinate, or at this spot, we have the coordinate 1, 0. So this is where the sine is equal to 0. This spot, the coordinate is 0, 1. So this is where the cosine is equal to 0. This is, I made my circle a little too small here, but this is -1, 0. So this is another place where sine is 0. And then this is 0, -1. So this is another place where the cosine is equal to 0. Okay. So cosine is equal to 0 top and bottom. Sine is equal to 0 left and right. Okay. That corresponds with these values. Now let's talk about how we're going to name these things. And again, this naming is going to come up over and over and over again. So if we're talking about where the sine is equal to 0, and we're going to talk about this in radian values, we could also talk about it in degrees, but radians is going to be used more often. If I'm talking radians, this is 0, this is pi, this is 2 pi. If I kept going, this is 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, and so on. I think you get the idea, okay? So sine is equal to 0 at, and this is how we're going to call this, multiples of pi. Okay, so sine is equal to 0 at multiples of pi. 1 pi, 2 pi, 3 pi, 4 pi, and so on. Okay, the cosine is a little more complicated. So cosine is equal to 0 here and here. So let's think about what these are called. This is 1 pi over 2. This is 3 pi over 2. If I kept going, technically this would be 4 pi over 2. So this would be 5 pi over 2, 7 pi over 2, 8, 9 pi over 2, 10, 11 pi over 2, 12, 13 pi over 2. So what are you hearing there? This is pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2. The cosine is equal to 0 at odd multiples of pi over 2. Okay, that's how we're going to say that. So you might be thinking, what happened to the even multiples of pi over 2? Well, the even multiples of pi over 2 would be like 2 pi over 2, 4 pi over 2, 6 pi over 2. And if you simplify those, they turn into the multiples of pi. So really, these, the multiples of pi, are even multiples of pi over 2. Okay, I don't usually call them that. I usually just call them multiples of pi. But if you listed them as even multiples of pi over 2, that's okay with me. Okay, so these are the evens. These are the odds. Okay, so that being said, to actually answer our question here, and I think I'm going to get these lines out of here because they're just going to get in our way. The tangent is undefined when cosine is 0. So this would be odd multiples of pi over 2. The cosecant is when sine is equal to 0, so that would be multiples of pi. Secant is when cosine is equal to 0, so that's going to be the same as the tangent. So this would be odd multiples of pi over 2. And cotangent is when sine is equal to 0, so that would again be multiples of pi. Okay, if you want, on this circle that you drew for yourself over here, let's mark down where the undefined values are. So at these 2 points, the undefined things are the things where the sine is equal to 0. So this would be the cosecant and the cotangent that are undefined. Up here, this is the tangent and the secant that's undefined. Okay, and that same thing's going to happen down here. This would be tangent and secant, and this would be cosecant and cotangent. And again, plain old sine and cosine, you're never going to have undefined values there. You always can find sine and cosine. It's these other 4 that give us problems because they come from fractions with trig values on the bottom. So like I said, for today, just knowing those 6 things is going to help you. We are going to be using this and talking about this, and this is not the last time you'll see me draw this diagram. Next time I'll probably draw it a lot bigger, but this will be helpful to you as you move forward. I forgot to mention this at the beginning. These notes actually go into like the next couple of pages, and it talks about the graphs of these functions. You really don't need to know the graphs at this stage of the game. You really need to know this stuff. And so for a couple of reasons, I'm not going to cover the graphs right now. One of the reasons is that you don't really need to know it right now. And secondly, it kind of depends on you knowing the original trig functions graphs. So it depends on you knowing what the graphs of sine and cosine look like. And if you're watching the video the year that I made it, I mean, I'm sure I'll keep using this video in the future, but this is 2020 that I'm creating this video, and those of you who are taking the class right now did not learn the sine and cosine graphs last spring. So it wouldn't make much sense for me to try to teach you these other ones because you haven't learned those original ones yet. We will get there. So that's going to come later in the chapter. But for right now, I am just going to cover these 2 examples and call it good. That'll be enough to get you through the homework assignment and through everything you need for the first part of this chapter. Okay, I think that's it from me. Hopefully that was helpful, and I will see you next time in class.